Artificial intelligence appears effortless. Ask a question, receive an answer within seconds. It feels almost magical. But intelligence doesn't appear from nowhere. Before an AI can generate a single sentence, electricity must already be flowing. Before electricity arrives, power plants must be operating, transmission lines must be connected, substations must remain stable, because every intelligent response begins as electrical energy. The internet doesn't run on software, it runs on power. The question is, how much power and who is building it?
Every civilization depends on energy. The Industrial Revolution ran on coal. The 20th century ran on oil. The digital economy runs on electricity. Not because electricity is new, but because computation cannot exist without it. Every processor consumes power. Every memory chip consumes power. Every storage system consumes power. Even cooling systems consume power. Artificial intelligence doesn't replace electricity. It multiplies the demand for it. The age of intelligence is becoming the age of energy.
For decades, technology companies searched for faster processors. Today, they are searching for something else: reliable electricity. Because processors without power produce nothing. The fastest AI chip is useless without energy, without cooling, without infrastructure. Something unexpected has happened. Technology companies have become some of the world's largest energy customers. Not because they entered the energy business, but because the energy business became essential to the technology business. Every search activates servers. Servers consume electricity. Electricity creates heat. Heat requires cooling. Cooling consumes more electricity. The cycle repeats. Every video streamed, every email delivered, every AI image generated, every cloud application opened consumes energy, usually only a tiny amount, but billions of tiny requests become enormous demand. The modern internet is no longer just a network. It is one of the largest electrical machines ever built, and every year it grows larger. Most people believe AI runs on chips, but chips cannot think without power. Before computation begins, electricity must arrive. Not once, every second, every hour, every day, without interruption. That is why every hyperscale data center is designed around energy, not servers. Power. Every rack, every processor, every network switch depends on stable electricity, because 1 second without power can interrupt millions of digital experiences. Infrastructure isn't built for average days. It is built for the unexpected, because reliability is the real product. More electricity creates more compute. More compute creates better AI. Better AI creates new businesses. New businesses create more demand. More demand requires larger data centers. Larger data centers require more electricity. The cycle accelerates again and again. This isn't simply technological progress, it is infrastructure compounding. Every new generation of intelligence requires another generation of energy, which explains why technology companies are investing far beyond processors. They are investing in the systems that keep processors alive.
The competition has changed. Yesterday, companies competed for users. Today, they compete for megawatts. Because compute can be purchased, buildings can be constructed, even processors can be manufactured. But electrical capacity cannot appear overnight. Power plants take years. Transmission networks take years. Grid expansion takes years. Infrastructure moves at the speed of engineering, not the speed of software. And that changes everything. The companies securing tomorrow's energy may also be securing tomorrow's intelligence.
Energy creates compute. Compute creates intelligence. Intelligence creates productivity. Productivity creates growth. Growth creates demand. Demand requires more energy. The cycle repeats, quietly, relentlessly. Notice something. Artificial intelligence isn't just changing software. It is changing infrastructure, utilities, power companies, grid operators, renewable energy developers, even nuclear energy. They are becoming part of the modern internet. The internet is no longer just a communications network. It is becoming an energy network. When you ask in AI, it feels like a conversation. But before the answer reaches you, another conversation has already happened between a power plant and a data center, between the electrical grid and thousands of processors, between infrastructure and intelligence. The answer doesn't begin inside the AI model. It begins where electricity is generated, because intelligence is simply electricity organized by infrastructure. The smarter our machines become, the more important energy becomes. Perhaps the future of artificial intelligence will not be limited by algorithms, but by electricity. Most people believe the AI race is about software. The real race may be about power. Every civilization depends on one critical resource. For centuries, it was food. Then it was coal. Later, it became oil. Today, the defining resource may be electricity. Not because electricity changed, but because civilization did. Every digital service depends on it. Every cloud platform depends on it. Every AI model depends on it. The internet doesn't simply carry information, it transforms electricity into intelligence. And perhaps that is the most important transformation of the modern age. The next breakthrough may not happen inside a laboratory or inside a software company. It may begin inside a power station, inside a transformer, inside a transmission line. Because before intelligence can scale, energy must scale first. Every new generation will demand more computation. More computation will demand more electricity. More electricity
will demand more infrastructure, and infrastructure will shape the next generation of the modern internet.
Every message travels through networks. Every network depends on servers. Every server depends on electricity. Every electrical system depends on infrastructure. The experience feels instant because millions of systems operate together, silently, continuously, reliably. That invisible network is the foundation of the modern internet. If you enjoy exploring the systems behind technology, the infrastructure beneath innovation, and the capital shaping the modern internet, subscribe to NEXNET and tell us, what hidden infrastructure should we uncover next?
The future of the internet will not be defined only by faster software. It will be defined by stronger infrastructure, more resilient networks, greater computation, and the energy that makes all of it possible. Because beneath every search, every AI response, every cloud application, and every digital experience, electricity is always working, invisible, reliable, essential. This is NEXNET, inside the modern internet.